Hello and welcome to another episode of the Oxford MAT Livestream. This time, logarithms and powers. Great to have you with us if you're watching live or watching the replay. It's the first day of September for the live recording. I think that means schools have gone back, which I think means there's going to be a bit more of a chill one live. If you're watching the replay, then so is everyone else. But Albane is here, so hi Albane. His first time writing in chat, or maybe welcome to chat. If you want to join live chat because you're in chat live, then that's over at slido.com/OOMC. No, /MatLive, not /OOMC anymore. Set it on autopilot. I'm well, thank you. Hello, anonymous people. Hello, person whose username is MamesJohnro. Hello to Zach, and I think I saw Jack in there as well, and a few other people as well. Hands free, because today we are joined by, everybody say hello to Prisma. Prisma is one of our current students who is helping out today so brilliantly by moderating chat so that things just appear without me having to click on them. It's the future. The link's on screen and I still read it out wrong. So, from your point of view that was embarrassing and terrible, whereas from my point of view it was just incompetent. Good to have all of you with us. We're going to do a quick poll because I can. The poll is, how was your day today? And the options are star ratings out of 5. Albane, this might be your first one if you're joining in chat live. Here's how it works. I'd like to know how your day was. One person straight in there, straight on the 5-star button. Right in as soon as the pop-up came up in their app. As always, if you're having a great day, that's fantastic. If you're having a terrible day, then I'm keeping an eye out for you as well. Look at that. That's like Benford's law, but backwards. It's like, or is it exponential or something? Oh my goodness, right, okay. There's people voting 1-star or 2-star. However your day's going, you have logged into a MAT live stream to see some maths happen, so at the very least your day will include logarithms. I'm a huge fan of logarithms. For me, they increase my star rating for the day by at least 1. Somebody left a YouTube comment recently on one of our old videos saying too much waffle, and I don't think they realised that it wasn't live and they were watching it and they could just fast forward. So I suppose if you're watching the replay, you can just fast forward this bit. I'm just going to chat to the people who are here today. Actually, I've lost them because they're behind the poll right now. There's some questions. People are recognising that Prisma's back. Prisma did some Prisma did some maths club stuff before as well. Prisma's replying to some people in chat. Somebody's asked how my day's going. My day, I think, solidly like 3 or 4. Not really sure. I think I'll probably vote 3, and then hopefully I'll vote 4 at the end of what's going on here. Yeah, it's an exponential or something on the logarithms live stream and powers. Somebody's asked what the workload's like, which is a tricky question, I guess, since I'm not a student here. Maybe Prisma, who's a current student, will type some sort of reply. Maybe they currently are typing a reply. Who knows? Oh yeah, no, they were. They literally were. That is how in sync I am with the student moderator today. Prisma said it's a lot of workloads today. A lot of workload. Cool. Currently the break. Right, cool. People are voting. Overall, we're at 4.0, which is, I think, the highest average I've ever seen in one of these How's Your Day polls. So that's pretty good. That is pretty good. So good. Right. Well, maybe the logarithms. Maybe it's just downhill from here. Curry was good. Thanks for checking in. Good. Right. Okay. Good vibes only. Huge fan of logarithms. Can't wait to do some. This part of the syllabus is extremely short. Look. So this is literally part of the MAT syllabus where I took the one-page syllabus of everything we think you know, not everything we think you know, but everything that is relevant that you definitely know by the time you do maths because of sequencing in maths lessons. And this is all we can think to write about logarithms, that you know some laws of logarithms. We're going to explore a few of them today, and we're going to maybe discover a couple of others. Maybe we'll discover some logarithm laws. Maybe we'll work out some other stuff, other sort of shortcuts and tricks. And some exponentials. Prisma's been in a video. If you would like to see Prisma's face, they're not on screen today, but Prisma's in a video on metric spaces. If you go to the Maths Club website, which is OOMC, and Control F Prisma. Cool. Right. Good. Laws, logarithms, and exponentials, and also the thing that you do with logarithms. No, I'm going to read it out. Hi. One thing about me not moderating chat is I'm going to miss stuff. That's just fine. I'm just going to go with that. That's the side effect of me not getting distracted by reading out everything in chat. Lowest and highest, yeah. So the how is your day is sometimes really low. I sort of expected, because people are back in school, I sort of expected it to go down. It's gone up. I don't know. Maybe you all love school. Maybe you're just at the peak of end of holidays before you go back to school. Who knows? Okay, so I tried to list out from the MAT syllabus, there's a very terse little line about what do you know in what do you know about logarithms. I tried to list out what that is. If you haven't learned about logarithms yet in school, then this is probably a terrible way to learn about logarithms. There are probably other websites out there where you can learn about logarithms much better, but this is going to be a very fast way to learn about logarithms, so we're going to do that now. Hopefully most people are doing this as revision. This is just for like are there any sort of year 10s who have tuned in, or any sort of year 9s or year 11s who have tuned in just to quickly learn about logarithms? I'm going to try and teach you logarithms extremely quickly. First, remember how powers work. Powers work like this, that you add together the powers when you multiply, like a to the m multiplied by a to the n. You add the powers together like that. I think you already know that even in year 9. So your examples might be like 2 squared times 2 cubed. It's the same thing as 2 to the 5. The thing you do is you add the 2 and the 3 together. There's also this thing about powers of powers, which feels like it should be really exciting, or make something even better than powers. But if it's done in this order, then you get, so if you've got a to the m to the power of n, that means a to the m multiplied by itself n times n copies of that multiplied together, which is the same thing as a to the m, a to the m, a to the m, a to the m dot dot dot, n of them. So kind of by the addition rule above, that's the same thing as a to the power of mn. This is not the same thing as a to the power of m to the power of n in general. There are some examples where this turns out to be the same number, but some examples where it turns out to be the same number, but mostly these are not the same thing. You should not mix up whether the brackets are around this bit upstairs or whether the brackets are around the bit that's downstairs. These in general give you disastrously different things. So getting sidetracked about homework, maybe you could try and work out if all the numbers are bigger than 1, which one of these things is bigger. I think it's probably this one, but something to think about outside. But we're doing a speed run, so we're going quickly. Right, okay. Hi to the person who's anonymous and said hi loads. And some people are back to school next week, so I'll do my poll again next week and we'll see whether school has improved or disimproved your attitude. Yes, I've put positive numbers in here. Why have I put positive numbers in here? Not really sure. Yeah, that's a good point in chat. Kai says, why have I put positive? Do I need positive here? Maybe I don't. I'm just a bit suspicious. Yeah, because I want real numbers m and n. I want to do real powers, and you can't do fractional powers or irrational powers of negative numbers. So I want a to the m to be defined. So I put this disclaimer in so that a to the m is okay. Smiley face. You need a to be a positive number in order for that to mean anything. In general, you can get away with it sometimes if m's a whole number, but because I want m to be some real thing, I've restricted a to be positive. There are other cases where you could get away with it working. Cool, good question. A little bit sidetracked, but we're going to go. SV, if you get the right answer, you'll get the marks, so you'll be okay. If you get the wrong answer, then we might come back and look at your working, in which case, if you don't put any working, there's nothing for us to look at. But in which case, if you have no working and you've picked the wrong answer, I tend to assume that you guessed, but I don't know. Cool, good. Oh no, it's the non-official MAT countdown reminder. I expect that to be extremely unpopular for some reason. I don't know, it just feels like it's going to be unpopular. No, it's got 2 thumbs ups already. I'm wrong. Non-official MAT countdown reminder, more popular than expected. Good, right. Powers down here as well, so remember negative numbers. That's the same thing as doing fractions like this. A to the minus n is 1 over a to the n. And it's nice facts that a to the 0 is 1. As long as your number a is non-zero, there is like this whole separate thing about what is 0 to the power of 0 that we are not engaging with today. Today we will not be thinking about 0 to the power of 0 as much as we possibly can. It's, I think, safe to say that the safe answer is it's undefined. I'm going to stick to defining things with positive things. If you don't really know the answer to a question, is it worth guessing? For the multiple choice, yeah, you'll get the marks if you get it right. Guessing is fine. You get the marks, the multiple choice. If you don't guess, if you don't tick anything, you will definitely get 0. But if you tick, then you might get some marks. Good, right, okay. So, logarithms. If you're learning these for the first time, then again, I'm so sorry that you're learning about live streams from some sort of logarithm. But, you know, here we go. Sometimes you want to solve an equation like this, a to the power of x equals b. Examples are, I guess, maybe you just want to find out when an exponential is equal to a particular number. Or more realistically, maybe you're trying to work out when your compound interest will finally get to some particular target. You know, if you're getting 1% interest every year and you want that to finally be doubled, to have doubled your money, you might want to know what that number X is, like how long it's going to take. Compound interest works like that. Some people really care about money, some people don't. So who knows? Okay, there's some notation for that, which doesn't really answer the question, right? But the notation for the solution is you would write down that, my solution to this is the number x. It's log base a of b. This is just some weird notation that we use to remind ourselves of which number was downstairs and which number was the thing we were aiming for, the little target for our exponential function there. And this is sort of a little bit unsatisfactory because it's just introduced some new letters, log, and it's like, well, this is the number that's defined to make that work. Maybe you can imagine there are some special situations where we might know what the value of x is. So if we're solving 2 to the power of x equals 4, then we know that that's the number 2. So you kind of already know that this is equal to 2, that you square 2 in order to get 4. But in general, who knows how we're going to work out that logarithm. Luckily, your calculator has a logarithm button. If you don't have a calculator, like in the maths where you don't have a calculator, then working out logarithms is a bit tricky. And there is some techniques for doing it, but I don't think you actually learn any of them at A level. So a bit like how you have this mysterious sine function, where what's sine of 3? I don't know. You have to work it out somehow with a calculator or something. We've got this new function called logarithm. It comes in different flavors for these different numbers down here, depending on what powers we're working with. Popular choices of flavor of logarithm are logarithms. This is called base 10. So logarithms like this can be a little bit confusing. I'm going to put a little x in here just to think about this, where I'm changing, maybe I'm keeping the 10 constant, but I'm changing the target number. So Kai reason, this is good advice. What power do you need to raise a to get b? So this means, what power do you have to raise 10 to get x? So if x is 100, then the answer would be 2. If it's 1,000, it would be 3. If it's something in between 10 and 100, the answer is somewhere in between 2 and 3. This is a popular flavor of logarithm. Some people also use log base 2 of x. Log base, there's this special one which is 2.78 1828 459 452 that doesn't sound very useful but is extremely useful, and it's not important right now. Why? It does some really nice stuff. This number is called e. This function is sometimes written as ln of x for log base e of x. That's an e down there, which is sort of nice. These are my top 3 logarithms, I guess. My top 3 logarithms, e, 2 and 10 on the bases. There is a Taylor series. You definitely don't need to know about Taylor series right now. Some people in chat have spotted that I was avoiding saying the phrase Taylor series. If you guessed, you get the 4 marks, but if someone saw the transcript, I would be less likely to get. If you guess, you get the 4 marks. If they then look at the transcript, they'll probably assume you did the bit on rough paper, even though we asked you not to do it on rough paper. But I think I would assume, if I looked back and saw, I think I'd assume that you did it on a rough paper. Why have I memorised so many digits of e? I had a crisis there. I wasn't even sure because I haven't recited e for a long time. Maybe I should look it up a little bit. Look it up in a minute. 2.78 1828 1828 4590 452. Yeah, that's only 20, right? Maybe I should know more digits of e. Right, cool. It's just some random number, right? For our purposes today, it's not important. Why is James know 20 digits of it? Not important right now. Good. Right. Okay. Yeah, so like with sin x, sometimes we omit the brackets, sometimes we write this function like this. Sometimes people get really relaxed with it and they start writing out just log x like this, where you're supposed to have remembered which base they're using, which flavour of logarithm they're using from context, which is a bit dodgy. But it's something that some people do there out in the world. Oh, 7, there's E in chat. Why didn't you change your username to E? You missed the chance to say E as your username. 71828 1828 459 452. Yeah, and then the next bit's hard to remember, 35360. Speedrunning it though, come on. E is really nice to work out digits of. I can't resist not telling you, right? E is equal to 1 plus 1 over, 1 over, let's get this right, is equal to 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial plus and so on and so on and so on. This converges really, really quick. These terms get really small, really fast. So if you work out just a few of them, then you get a really good approximation for E. This is just some nice fact about how series go. Good. That is how you might work out digits of E. Good. Cool. Really getting distracted. It was not helping my speed run through teaching people about logarithms. It's now probably confusing that I've told you about this weird number E and not said anything about what it's for. But hey, it's probably worth talking about the graph. So here, again, people, when you've chosen your base A, which people sometimes pick 10 or 2, you can think about this as being, you throw different inputs into this function, like it's a function. So you're asking different questions. What number should I raise A to the power of to get X? The graph of that function, so if you try and draw y equals log base A of X, the graph of the function, we talked about it last week with graphs, or was it 2 weeks ago? I think last week with graphs. Looks like this. Is it maybe 2 weeks ago with curve sketching? Maybe 1 week? Can't remember. It looks like this, which says that if you want to get a big number, you need to raise A to the power of a bigger thing. But because A to the X gets big really quickly, in order to get an extremely large value, you only need to change the value of your power just a little bit in order to get much more extreme large values. That's kind of why it flattens out. I am trying to teach this not in the way that you have heard it before. I think Prisma is typing an answer to that question. I'm going to do this one. Oh, some people think it defaults to base 10. Oh, I missed a 1. Did I miss a 1? Oh, that's a shame. Oh, thanks, Ben. You've really... Oh. Why does James know? 20 digits plus a bonus 8. That is sad. You're correct though. I put an 8 in here. There we go. 2.7. Right, let's try and learn it now. 2.7. 1828, 1828, 4590, 452. Is it better or worse that I knew the next 12 digits without? Oh goodness me. Right, cool. Yeah. So lots of people in chat seem to think that it assumes to be 10. Maybe that's true at school. By the time I was doing my research, including in my PhD thesis, there's a whole bunch of logarithms where it's, from context, we define it to be the one with base E, which is maybe weird because I just told you that some people have invented a different phrase, lnx, for natural logarithm for that one. But for some people that one means E, base E. Good. Where does the log function cross the x-axis? Right, that is a great question because it tells me that somebody in chat is learning about logarithm. So, right, we're going to learn logarithm together. So here's your question. When does log base A of X equal 0? So let's try and do that in words. This is the number on the left, where A to the power of this thing would be X. Oh gosh. Oh my goodness. A to the power of this thing on the left would be X, and this thing's equal to 0. So you're telling me that so we want the number which, when you do A to the power of that number, you get 0. So we could write, I guess, no, sorry, when you do A to the power of 0, you get that number. I think these are synonymous. Sorry, I really mangled that. Going to try again a little bit. Rewind slightly. Don't rewind the video, you'll see me saying it wrong again. Playing it wrong as well. When does log AX equal 0? Well, that's the same thing as saying that A to the 0 is X. Maybe you're ahead of me and you've worked out, aha, that means it's the number 1. This point here is 1. In fact, that's true whatever A is. Because of that fact that A to the 0 is always 1. We don't talk about base 0. Yeah, okay, so you've been taught that log x always means base 10. Cool. Oh, and Ben, no. Anonymous person says, look at your calculator. Where it is, oh my goodness, the log button. The log button defaults to 10. Disastrous times. That is a good thing to know. Right, okay. Any other scenic points on the log graph? It gets really steep over here. Because if you want to get something that's really close to 0, then you need to raise A to the power of something very negative. Here's the graph of A to the x, if A is some positive number. A is positive. So if you want to get something really close to 0, which is what's going on near here, if you want to get something really close to 0, then you need to take a really, really negative value for that power. Okay. Good. Request from chat. I can do this now. A request for a version with spaces in, for writing in. It's a good question, and I have just today, before we went live, produced the spacey version. If you've watched previous episodes, you'll know that I messed up the spacey version, and I haven't released it to you before because it's slightly messed up, and it's actually a little bit broken, but today I spent the time to actually fix it. So it's now fixed. And that means I can release it, so there'll be even more PDFs on the website soon. ish, soonish. Good. Oh yeah, so there's another special feature. It was on screen as well. Look, here it is. Log base a of a is number 1 because that's the solution to a of x equals a. That's number 1. Okay. We're sort of trying to solve all of these equations that look a bit like a to the something equals b. And if we know what the answer is, we're sort of reversing it twice. Anyway, what does the graph of 1 over log x look like? There's a question in chat. So let's think. Well, we know that at 1 log x is. We know that at 1 log x is 0, so this thing is really big, and then it's positive, and it comes down like this towards 0 because log x takes its time, but it does get very big, so this will come down very slowly. Over here it's negative, and it's going to come really close to 0 over here, like this. There we go. Vertical asymptote here. Good question. A little bit like the graph of 1 over x, but there we go. Is the live stream from last week going to be put online? Great, it is online. I just forgot to put it in the table of links. If you're on this YouTube channel, then you can just scroll back to it, but that's a reminder that I forgot to put it in the table of links. How am I going to remember to do that? I'm writing myself a post-it. Cool, right. Good. That's how we're going to remember to do that. How are we doing? We're learning about logarithms really quickly. Some would say too quickly. Oh goodness, there's 100 people watching. That's right, good. Maybe I should not be doing post-it notes during. Thanks for watching me write a post-it note, 100 people. Yeah, here's logarithms kind of cancel out. They're like the inverse function for powers. So if you try and read this out in words, it's complete nonsense. It's really hard to pass. But a good fact you could use, if you ever see log base a of a to the x, maybe a to the x has been somehow disguised, like you've seen log base 2 of 4 to the x or something. Well, hang on, I know some power rules. That's the same thing as 2 to the 2x. Aha, that's equal to 2x. You can use the kind of logarithm kind of. It's the antidote for powers like that. That's that point of logarithms, really. Good. Right. Cool. Let's not all remind. I have to post it now. I have to post it. It's going to be fine. Look, here's my post-it. I have to post it. It's all ready to go. We're going to be fine. Cool. I've never really used this fact as much as you might expect, but the inverse is the other way around as well. That you have a to the power of log base a of x is equal to x. I never really know. This fact, I suppose, when I've seen it, you can use it to replace. If you've got something like x cubed, and for reasons known only to yourself, you would like to write it as a to the power of something. Well, writing a to the power of something is it's a very sort of logarithm kind of thing to want to do. In particular, you could write that x as log to the power of a log a x, and then the thing is cubed, so this is the same thing as a to the power of log a x. I don't know. Sometimes you maybe want to do something like that to replace a nice friendly x with something that has a downstairs. Goodness me. If we say x equals y, can we say that log x is log y? Yeah, that's true. Log is a one-to-one function for positive numbers. So yeah, let's put it on the board. If x equals y and they're both positive numbers, then log x equals log y. Why am I being so weird about saying that they're positive? Well, I don't really want you to put negative numbers into these logarithms. Powers can't take negative numbers, so there's no answer to the question, what power of a do I want to... I've put my a's on the logarithms. What power of a do I want to get this negative number? So you can only really put positive numbers into logarithms. At university, you learn things because at university you learn an amazing way to do logarithms of other stuff, including negatives. Yeah, SV says integration, but yeah, I mean, if you've got like a 3 to the x integral, but people watching this live stream don't know how to integrate e to the x necessarily. I mean, we sort of do, but let's see what SV says. Come on, I want to expand on SV's point really quickly. So we haven't done this on the live stream yet, but you know how to differentiate e to the x, right? You know that you can differentiate e to the x to get e to the x, and that means you also know how to integrate e to the x. You get e to the x plus a constant. This is the nice thing about e to the x. That's that number e, by the way, with 2.7, 1828, 1828, 459, or 452, 35036, because it does this in ways that other powers don't. There's a trick which I would never use on the mat. I think probably not. No, I can't really see using this on the mat. But if you want to do an integral of something like 2 to the x, then a clever trick you can do is to write that as e to the ln2 times x dx, and then go from there to use the fact that you know how to integrate. I suppose you know how to integrate e to the kx because you know facts like this. So integral of kx is e to the kx divided by k plus a constant. There's kind of this extra factor of k around in places where you might expect it to be. So this thing is then e to the ln2x, e to the kx divided by k plus a constant, which you can then simplify back to 2x over ln2. I would never do this on the mat, but hey, here's a kind of cute thing you can do using logarithms and things like this. Good. Okay. Carl Frederick Gauss in chat has risen from the dead to shout complex numbers into the chat because we got there. There's a kind of Easter egg hidden in every episode, that every episode contains some sort of tangential reference to complex numbers. Today it was that the trick that you learn at university for dealing with logarithms of negative numbers is complex numbers. Plus e. I hope it plus e. Do I need a plus e? No. No. Wait. Okay, right, good. Okay. So there are some rules of logarithms that don't clip this. I mean, you can clip this, but I'm suspicious because this feels a lot like to zoom in on that point. Sorry. To zoom in this trick, it's this feels a lot like integration by substitution. The trick to get from here to here. I mean, it's not quite a trick. It feels a lot like integration by substitution, which is not on the math syllabus, which is why I'm saying it's probably not okay to do this, because you know about e to the kx, really, but it feels a lot like integration by substitution. If you've done integration by substitution, you're probably much more comfortable doing this step. So there we go. Right. Good. Sorry, that's me laughing at the phrase e to the I pi go brr, which never fails to amuse. Right, good. So there's some rules about logarithms that you can sort of prove these using what you know about powers and what you've maybe just found out about logarithms. They're not that mysterious if you interpret them in terms of the only things we know about logarithms so far, that they're defined to satisfy particular equations. So this number on the left here means the number that you would raise a to the power of to get xy. And the thing on the right-hand side is the sum of two things, kind of because of how powers work with sums. So that's one way in. So this is just some rule. If you see log base a of x times y, that's equal to log base a of x plus log base a of y. That's quite nice. You can use that sometimes to simplify things. And you can generalize it to, if it works like this for products, then you can work out how it works for powers. It's k times the k. I imagine this, I think I'm maybe too visual on this sort of thing, but I imagine it with the k kind of moving out the front. Okay, for me, when I look at this logarithm, the k kind of drifts out like this way, out to the front. I don't know. I just like I enjoy like imagining things moving around. Like same thing with manipulating equations as well. When I see something like this, the power of k here just can come down the front, so that it's out the front. Some people really hate thinking like that, so let's erase that. You don't forget about that rule about powers working like that. This one comes up. Oh, this is just a great fact that log base a of things look like this. So you can actually deal with fractions as well, I suppose, because you know about the multiplication rule. And fractions are just fancy multiplication with a power of -1 in there somewhere. So we're good. Okay. Cool, that law is nonsense because I didn't specify that x and y had to both be positive numbers. There we go. Today, everything that we're putting in logarithms today is positive. Over here, x is positive as well. K is real. Oh my goodness, there we go. Good. Yeah, there's not equal log -1. Yeah, you can prove some weird stuff if you start putting negative numbers in. Lots of weird things happen. Yeah, so change the base law is not on this worksheet, but I wonder if we should discuss it because it's sort of about come up here, hasn't it? It's sort of come in here. Let's see if we can attack it from this angle. So this rule on screen is, on the one hand, it's just true that you can bring the k down the front. On the other hand, it tells you something about relationships between logarithms with different bases, because the facts on the board are all about powers of a, but you could also interpret them as being facts about powers of x. There's a way to get in here and imagine this as powers of x So, for example, if you write u is equal to x to the k, then you're perfectly allowed to write that k is log base x of u. And then you discover the amazing fact that log base a of u equals log base x of u log base a of x, which is just rephrasing this one, but writing u for x to the k. This rule is quite pretty. Some people, I think, really like it, especially if you write it, hang on, let's write it this way around. So I'm going to flip the terms around. Multiplication is commutative, yo. Because now look, it's like log base a of x, log base x of u, which is quite nice. So that lets you do some sort of change of basis stuff, change of base activities. Sometimes people want to put this one, if I move this one under here, told you I like moving things visually, right? If you move this one under here, then you have some expression that says if you've got log base x of u, we might use more realistic letters like a, b and c, I suppose, and you want to change it to different bases, then you can do it like this. Have I got all these things in the right places? I haven't messed this up, have I? Maybe I've messed this up. Quick look at chat. People like Prisma in chat. I saw someone asking about LGBTQIA, and I wanted to read out. Oh, I missed a logarithm pun. Yeah, log 0 and log negative was pretty bad. Can I read out what Prisma's doing great work, and sometimes answering questions, and you don't get to see them. So I sort of want to see. I feel like you did a really good answer to your question that I wanted to read out. What was the answer? So people in Prisma's joining in with like this Oxford Cambridge rivalry a little bit in chat as well. Okay, see anything good? Yeah, cool, good, right, cool. How did I get this new equation? I did a bit of shuffling. But I have really rewritten this, right? Have I done this correctly? So if I've called u is x to k, then this is definitely u inside here. And on the right here, this k is log base x of u, because that's what these logarithms mean for this new power statement I've written down. So I've got this kind of fact, I think. I've just replaced this k, and I've written it in terms of u instead of k. Change of thing. Good. Oh, got a bit behind on chat. Right, good. Yeah, okay. So if you got a favourite base of log and you want to translate all of somebody's logarithms into different logarithms, then go for it. World's your oyster. You can have, so instead of log base a of u, you can turn that into a log base x of u. Cool, we're going to look at this fact a little bit more. Yeah, I'm not bored of it yet. Yeah, okay, I'm getting bored of it now. There's some facts about, you can kind of short circuit this. So this has got 3 letters in. And if you want to copy this out to keep on a flashcard or something, then you can get the other MAT flashcards from the link in the YouTube description. But if you want to make a flashcard like this, I suggest that you use the letters A, B, and C, just to make it nice. Or just remember this one. And if you can remember this one, you'll be okay. So we've got 3 variables in here. If you plug 2 of them together, you can get a different fact. Let's do that one. So if A is equal to U, sort of special case, if A is equal to U, then this thing on the left is just the number 1. And this is log base x of A, log base A of x. So that's pretty nice. This tells you that you can switch the base with the thing inside so long as you flip it upside down. Who knows? Good times. Good times were had by all. Pierre de Fermat wants to know if they can do computational modules. Pierre de Fermat has come back from the dead. They have heard about computers. They'd like to do some computers. And the answer is yes, you can do a couple. If you're on the maths degree, you can do a little bit of computational modules from the CS department. Good, right, and the evil version of me, Mames John Rowe in chat, also likes the same sort of logarithm as me. It's about 2.7, isn't it? A little bit more than 2.7. Turns out I don't know how much more than 2.7 it is. Good, okay. There's a special name for the function that's e to the x. You can do all the stuff that we've done for general logarithms there, but with base e if you want to. And it's just written ln x, called the natural logarithm. I've never really understood why, it's ln for natural logarithm. It's like, I never really understood. Was it named by like French people or something? Logarithm naturel? I don't really know how that happened, but hey, not complaining. Should we do the worksheet? Yeah, question 9. Okay, so let's have a quick look at the worksheet then. So I did some warm-up questions, and there's one vote in chat to do question 9, which is this one over here. I'm not sure we've got time to do all of them, and some of them are just there to help you sort of warm up, I suppose, with practicing some logarithm stuff. If you haven't seen this before and you think that you would benefit from doing all of these, all of the warm-up stuff, then you can get this worksheet on the website, link on the screen. And if you want next week's one in advance, same link, you can get a week ahead if you want to, and do all the warm-up questions. We're going to talk about question 9. Are there other questions that people would like to talk about? Trying to catch up with chat a little bit as well. I don't have a poll for this. Maybe I should have a poll for this. You cannot do physics as part of the maths course, but there is such a thing as mathematical physics, where you do, so Blastoise, you get to do mathematical physics like fluid dynamics, quantum mechanics modules as part of the maths degree, just taught by the maths department. Log A, yep, so that looks like Firat's chat thing that just flew past. Log A over log B is equal to log base BA. That's the fact. That's the amazing triple fact that we had, where I assume your ones on the left are base 10, so you can set U to be 10 or something, and then do the fact on the screen. Fact on the screen is really good. I'm starting to think that it should get its own flashcard. Toto Wolf thinks that reading Lun is better. Oh, it's Latin. No way is it Latin. Is this a wind up? Is it Latin? No way is it Latin. Okay, this is a thing to look up. Good. Right. Cool. Am I really? Oh, is it vote for question 6? Sorry, someone just says 6 in chat. I like question 6. I'm not quite sure it works. Please don't think too hard about question 6. I think it might be fundamentally broken as a question, but we're gonna have a go at question 6. Maybe nothing else. Do you need 75%? Says Ishak. The answer is no, not necessarily. There are charts. And an anonymous person has tried to annoy me by telling me that Pioneer both exactly the number 3. Good, okay. We're going to solve, so for question 9, we're going to solve it. We're going to solve it in the sense of writing it in terms of a logarithm. Maybe that question could be phrased better. Okay, so chat has spoken. We're going to do questions 6 and 9. Right, okay, let's go. Okay, so this one says we're going to use letters, and because I'm unimaginative, I've picked the letters A and B. Maybe I should have picked better letters, but hey, I've given you these two constants, natural logarithms, because they're my favourites. We've been asked about these quantities. This one, I think I wanted you to spot that that's 2 to the power of 10. Not quite sure, it depends a little bit how much you like computers, I suppose, or how much you like powers of 2, whether you notice that that's 2 to the power of 10 or not, but hey, so that is then equal to 10 times log base 2, because the power comes down the front, which is 10 times A. Cool. This one over here, ln of 40, well, that's obviously 4 times 10, isn't it? But 4 times 10 is not great. I suppose it's 4 times 2 times 5, which is then ln 4, ln 2, ln 5. I'm silly, I should have taken out a factor of 8 rather than taking out a factor of 4 and a factor of 2. These things are added together. So that's 2 ln 2 plus another ln 2 is 3 ln 2 plus a ln 5. I think that's 3a plus b. Cool. 1024 comes into the game. 2048. Thank you, Toto. Good. What's this one? So there's a square root in here. The square root is supposed to confuse you very slightly. Square roots are powers of half. So this is pull a factor of 1/2 out. A bit like that 1 over x trick. But 1 over x is just a power of -1. Square root is just a power of 1/2. So you can pull out that 1/2. This is 1/2 of ln 2 minus ln 5. Using the fractiony trick where this 5 is, it's sort of been multiplied by a 1 over 5. Multiply means add the logarithms, and 1 over 5 means put a minus sign in. In general, if you see a fraction like this, you can split it apart into its kind of numerator and denominator like this inside the logarithms. This is half of a minus b. Yeah, question 9, please just leave in those logs. Good. Oh, there's a vote for question 4 from Lando Norris, who uses driver number 4, so that's probably for the best. This is a 1 over sort of trick over here as well. It's negative of log 10, natural log 10, which is minus, I guess, a plus b. So a plus b all times -1. And this 1.024 is related to 1024, right? It looks really complicated, but actually it's not too bad because it's just log of 2 to the 10 divided by 10 to the 3. And we already know about log of 2 to the 10, and we already know about log of 10 to the 3. We did those in, well, I suppose we can work out log of 10 to the 3. It's not too bad. In terms of these things, this is 10a minus 3a plus b, or something like that, which is 7a minus 3b or something. This is the plan for the question, to try and get you to mess around with those laws of logarithms, to expand things out into these kind of atomic parts and then stick them back together and rearrange them a bit. I think it is fundamentally broken because b is just some multiple of a. They're not actually independent variables, they're just numbers, and one of them is just bigger than the other. So you can write all of them in terms of a if you want to, but that's a bit messed up. It's not quite what I wanted people to do. Good. Let's do question 4 next, because it's right here. Question 4. Good choice as well, because it's foreshadowing for a later question. Question 4 is supposed to be a bit weird, that it's got this log with a weird base in it. The plan for what I wanted you to think of for this one, you're kind of a bit stuck. There's not very much you can do. It's not pure multiplication inside. You can't really get rid of this plus sign, right? It's really annoying. You can't really... I guess you could write it as log of base. If you really wanted to, you write it with log base x plus 5 log base x plus 5 of 6 plus log base x plus 5 of x plus 22 over 6. Because you've got to divide the whole thing by 6. You've got to pull the multiplicative factors apart. But what Kai says in chat is a better idea, which is to turn this into, whenever you see log base a of b is equal to c, you're always allowed to turn that into b equals a to the c. So remembering that you get things the right way round, this is the equation x plus 5 squared, which is x squared plus 10x plus 25. So then rearranging and stuff, it's now turned into a quadratic equation, and we can relax a bit because we're good at solving quadratic equations. And it's this quadratic, which is quite a nice one as well. The quadratic is sort of, if you do all the worksheets, there's a sort of running joke about that quadratic. Foreshadowing question 4, good. Is Jack getting any love for that pun? Good. Jack's got 1 thumbs up for that. Okay, good. Yeah, thing squared. The thing squared is the other thing, and get rid of the log. Yes, perfect, good. So I quite like this as a sort of more abstract. It's like, how do we deal with problems? When you see a problem, what are we going to do with it? I mean, you can try using the laws. You can try, I've seen similar problems. I've seen other logarithm facts. I can try and use my logarithm facts to try and work with the logarithm, or you can just try and destroy the problem, get rid of problem, get rid of it. Which, it's quite sort of Gideon knot, right? Gordian knot? Gordian knot. Which is that fable about someone slicing a knot in half. I see a problem, slicey, there's no problem left anymore. That's a subset of the ancient story. The running joke with the quadratic is just almost every time I needed to put a quadratic into the worksheets, I picked the same quadratic to minimise the amount of time you waste saving quadratic equations when you don't need to. So that question was about logarithms, so then it turns into quadratic, and the kind of running joke is that it's always the same quadratic. I don't know if anybody noticed that. Maybe not. If you do all the worksheets, then you solve the same quadratic about 20 times. Sorry. Right, good. When you see a problem, just solve it. That's not as good advice as I thought it might have been. So the solutions to these are all going to involve logarithms. We're going to just write our answers in terms of logarithms. So like this one is going to be like x is equal to log base 2 of 3. For this one, we could write x is equal to log base 0.5 of 3. And for this one, we could just write x is equal to log base 4 of 3. Which is fine. These things are actually related to each other, so you can be a little bit more creative if you want to. But I would accept this as you've engaged with my warm-up problem if you wrote down these logarithms. You've got solutions in terms of logarithms on these ones as well. Solutions in terms of logarithms. I think we've done good work today. You could be slightly more creative though. If you want to get them in terms of looking kind of a bit more similar, these all look really different to me. But if you want to get them looking slightly similar, you could take, for example, this one, and you could write that as 2 to the 2x equals 3. So then 2x would be, that's the power, would be equal to log base 2 of 3. So x would be 1/2 of log base 2 of 3. Oh, so then, instead of looking quite different from the first one, you realise that x is just half of the thing that we had in the first question. If you want to make 3, you only need to raise 4 to the power of half as much as 2, because 4 is the square of 2. So it's sort of already two 2's multiplied together, pre-packaged. My PhD was on fluid dynamics, but mathematical. We did a lot of integrals. We did a lot of Bessel functions, Hankel transforms. Good times. You can do something similar over here, where this is 1/2 to the power of x. It's been cheekily disguised as the number 0.5, but we all know that's the number 1/2 really, which is 2 to the power of minus x. I suppose, because that's 2 to the power of minus 1 to the power of x. Being able to do the different laws and combine them together quite quickly is a good method to get faster at doing these, I suppose. So this is x is equal to minus log base 2 of 3. So it's just negative of the previous one. If you want to make 3 by raising 0.5 to the power of something, you should raise it to the negative of the thing that you were just thinking about when you were solving the 2 to the x equals 3 problem, because 0.5 is secretly just 1/2, so you just need the power to be negative, the previous power you were thinking of. So these things are kind of related, and if you are unsatisfied with writing your solutions like this, and you wanted to find some of the sort of hidden truth in the question, then hey, there's a hidden truth in the question that these are all related together. Maybe instead of solve, it should say something like find these in terms of each other or something, but who knows. Did I go straight from graduating from Oxford to your role now? No, because I didn't graduate from Oxford, because I didn't go to Oxford, but I did go straight from graduating from my PhD to working at Oxford. When's the soonest I can make new maths? There are no rules. You can make new maths. Normally, you wouldn't make new maths until probably PhD. At the earliest, that's quite a conservative guess. Probably possible to make something slightly new or remix something of it during masters, or maybe even third year project. People do a little bit of independent work in third year. If you're interested in really pure abstract mathematics, I would not expect to invent anything new before PhD, DPhil kind of level, just because there's loads of pure maths that's already happened, and lots of it's very cumulative. You have very builds on each other, but never say never. I'm not quite about going to that. Well, okay, right. Okay. Power discussions, nobody's asked about these, and some of them skirt really close to the 0 to the 0 question that we're trying to avoid. Did I do any new maths? Yeah. I solved a problem that was not previously solved, but is now solved. Debatable whether it counts as maths, because it was using techniques to solve a particular problem rather than inventing new topics or something like that. I don't really describe myself as inventing new maths. Anyway, we're now in a sort of chill out chat section before we do some math questions. We're warmed up. Things about me, which is very boring. I went to Trinity College at Cambridge. Hooray! Can you write this on random base to make whoever marks it convert the answer? Oh, right, okay. Well, I wasn't really thinking about doing it as a math question, Carl. I was thinking about rewriting this question for next year. So no one's going to mark it, because it's a question for the worksheet for you, future versions of you, whoever you pass on the Carl Frederick Gauss username onto for next year, so that it's maybe phrased differently, so it's more clear what I want you to do. Never mind. What's the problem? My problem is described on my website. If you want to find out about my research, there's a website for it. I don't really work on that anymore, so I'm going to not talk about it right now. Can't remember if I've done a live stream on my PhD problem. It's not super exciting to you guys. Fastest way is maybe applied maths. I'm not saying applied maths is easier. I'm just saying there's a lot of it going on now, and historically not as much. Historically, people did a lot of what I would consider pure mathematics. Recently, I think there's been a real explosion in people doing lots of applied mathematics, like me. Cool. Quick chat bit. It's not an Oxbridge war. Look, I've been to both now because I did it's the healing process. When you see a math problem, what should your initial thought process be, as in finding the right techniques to apply? Well, here's a math question on screen. Let's try and think of some thought processes. I would encourage you to think, does this look like any maths I've seen before? It's okay if the answer is no, but does this look like any maths I've seen before? So here there's a logarithm on the left of that equation. There's a whole bunch of other things in the equation, but there's a logarithm on the left. So if you've seen logarithms before, which I guess you have because we've just been talking about them for 50 minutes. If you're watching the replay and you fast forwarded the first 50 minutes to avoid all the waffle and you don't know about logarithms, then maybe rewind a bit to see a bit about logarithms. So there's something in this question I've seen before. Are any of the things that I know about that useful? Something we're trying to test for the MAT is you've got this kind of toolkit of things that at some point you learned in school. Maybe in separate lessons you learned these separate things and they're all somewhere in your head. What kind of commands do you have over that? Is your head? What kind of organisation do you have for you to be aware of the things that you know? We've made this very short MAT syllabus to remind you of the things you know. Are you aware of the things you know? Can you pull them out of your brain and apply them to different problems? This question doesn't say use the fundamental law about logarithms to undo the logarithm in the question, but it pretty much says that because you have to do that in order to make progress with the question. It just doesn't say that in words. It says that in problem. Good. Do I do interviews? Yeah. Do I do Trinity? Not anymore. Do the learning problems. Why do they do fluids? I liked it. I thought it was fun. I like the pictures. Stats for number if you got MAT in year 13. Number of MAT after A levels. No, I don't think we collect that statistic. Cool. Right. Cool. People are already trying to answer this question. Fair enough. Let's switch on a poll so that people can vote in some sort of voting method. There we go. Lando also put a method in chat, which is nice. The method, maybe we overdid it by saying that it was foreshadowing. You know, if you do foreshadowing and you say you're doing foreshadowing, it's less foreshadowing, more linear storytelling, I suppose. I would like to look at the chat while that's happening because the voting is secret at the moment. I'm going to look at chat and I'll just read out anything funny in chat. Has the MAT been written? Yes. What happened to the UKMT this week? Some stuff is going on with the UKMT. If you're watching the replay, let us know what's going on with the UKMT. And yeah, Lando's got the thing. Can you explain oblique? Oh, oblique. Is oblique? There's a request for a fluids thing. Oblique. Oblique. They want an explanation for oblique. So oblique is, I think, made of a mix of. Is that a word for the cornstarch and cornstarch and water? Cornstarch. It's a suspension of cornstarch and water. You mix together this kind of floury substance and water, and you get some sort of slime stuff that went really viral a few years ago. So that's exciting. It's really weird to play with because it's quite runny unless you push on it. And if you push on it, the grains of flour are really rough. There's lots of friction. So when you push on it, you're trying to quickly push those grains past each other, but there's lots of friction, and they push against each other, and it feels really stiff. It feels like a thicker liquid than it was a moment ago. So you have the kind of runny liquid, but as soon as you start doing anything to it, it behaves more like a solid. Kind of because it's sort of a solid and a liquid mixed together, right? So sometimes it's a bit like a liquid, sometimes it's a bit like a solid. Everyone finds this very exciting for some reason, but liquid and solid mixed together, sort of a bit like both, but hey, hey, I think it's pretty cool. Good, there are some votes going on. I think people are doing the thing that we did in the warm-up problem and rearranging this. I'm going to go on a limb and suggest that everyone who is making progress with this question has done something like this. Once you've done something like this, you've got rid of the logarithm, which was like a big problem element of the question, and it's turned into a kind of polynomials question. Quite a few MAT questions are like this, where you've got something that looks really awful to start off with, but then if you do something to it, it starts looking a lot nicer. Now it looks like a polynomial. I'm not going to see the rest of the question on the board. I'm going to relax. I'm going to see what chat thinks the answer is, because I'm pretty sure that chat has now solved some. Yeah, there we go. There are the votes. Chat has solved this equation for me. We're pretty good at solving equations. Solved this equation for me and told me it's got just two solutions. 94% is pretty good, chat. Well done. You are correct as well. But as an oblique kind of collection of people all together, yeah, 94% correct. Good. Push it. The trend to punch it. I thought the trend was just like Ryman's was selling slime or something. So that was weird. Okay. Right, okay. People are doing it. Okay, right. I've missed loads of chat while that was going on, and I was explaining Oobleck. Oobleck. Anyway. It's 2 squares. Yeah, it's a nice equation. It works out well. Well done, chat. Right, good. Chat's done great at this question. I love that. We got a few of these to get through. It's not even 6 log. Oh, we're doing really well. Who'd have thought? Getting Prisma along to help with chat. We're much more focused. We're much more speedrunny. We've only been distracted by reciting E, talking about complex numbers, talking about how you calculate E, talking about other rules of logarithms, talking about negative numbers a lot. We've been distracted by my PhD, the concept of Oobleck, whether or not Friedrich Gauss is alive, and just general admission stuff. Who'd have thunk? Who'd have thunk? So much faster. Only had like 8 major distractions. We got another logarithm question on the board. My theming for these is I picked out the logarithm questions from several years ago, the ones that looked the hardest or looked the most awful and disastrous. Yeah, thanks everyone who's listening. The list contains itself. That's pretty good. It's one of those lists that contains itself. Some lists contain themselves. Some lists don't. Don't think about that too much. Good. Right. Okay, question on the board again. It's really horrible. It's got lots of different bases on the logarithms. There's a base B here and a base A. 2 bases. It's pretty bad. And some powers of C going on to powers of A. So yeah, looks pretty nasty to me. We're asked whether or not it has a repeated root, which as a concept is just so far away from logarithms, right? Repeated roots is what people say about quadratics, and look, there's a b squared 4ac thing as one of the options. It's what people say about quadratics when they have a repeated root, when the quadratic is perfectly. Here's a different equation. Does it have any repeated roots? Doesn't look like a quadratic. Maybe it is a quadratic secretly. This, by the way, inside this bracket is b to the power of x to the power of x again, which is maybe fun to think about in a separate, when this question's all over and we've moved on with our lives, maybe keep at the back of your mind b to the power of x to the power of x again. What's going on there? We're going to destroy it in a moment. From this question, it's going to be obliterated. B to the power of x to the power of x again. It's pretty cool. I wonder what it looks like in, like, I don't know, Desmos or something. What does 1 over it look like in, like, Desmos or something? Good. Somebody thought about it too much. Yeah, good. I'm really glad we got there. Thank you, Anonymous. Let's do this question. Let's do it. We're just on a roll. It's going really well. You can not donate money to me. You actually can't. You can donate money to the Sutton Trust if you like. The Sutton Trust is a charity that I like. Good. It's terrifying when you see new questions. I agree with that. Let us go. Let's switch from poll. I can't find the poll. I found a poll. Has it got 5 options for this one? It does. There we go. Poll. Poll sadly hides chat while the poll's running. You used to be able to switch between the two, I think, but I can't find the button to do that. So we're just going to... I'll read out some chat while this is happening. I think, by the way, for the question, we should be trying to simplify it again. I'm going to get rid of some logarithms if we can. We've got this option, I think, of using some clever logarithm facts. If you're really clever with logarithms and you know... I'm saying clever, but I mean experienced. If you've done lots of things like that, that weird bit where we did x, u, and a all at once. If you've done a lot of things like that, then maybe this is your dream question. You've been waiting for this forever, right? It's just all those logarithm facts all at once. But if, like me, you're not like that, then probably you want to do stuff like just move the x down. It's a power, right? We know what to do with powers. You can just move the power down. And then maybe I'll do that again, right? I'll move another x. So I get x, log base b of b. Oh, that's all right, because x times x, you can just write as x squared. And log base b of b is just number 1. So this horrible term at the front is just x squared in a funny disguise. Probably do something with the other terms as well. B equals c at the end. Ooh, goodness. You're close. You're pretty close. Full correction of this question is like full solution. Okay, Lando would like a full solution rather than I do some of it and then cheat by looking at chat. Most of the questions are either way too easy or way too hard. So there's a Virat in chat. You should focus on the hard ones. Don't look at the solutions. Keep the hard ones. Copy them out on a scrap of paper if you want to, or carry them around with you in the back of your head. Eventually you'll find that you have an idea that's the hard question. It doesn't matter how long it takes you to think of the idea. If you carry around the question that's too hard for you to do immediately, if you carry it around with you, eventually you will have the kind of serotonin hit, the happy thing of having the idea and solving the question. After that, so the first time that happened to me, I was carrying around an exam and there were some questions I couldn't do. It was a past paper exam, I was carrying it around for ages, and it took like weeks until I saw something in maths class that reminded me, oh, this is a great idea, tell me more about this, this is brilliant, I see where we're going, this is going to help me do this question, this is amazing. It was not exactly, but it was a bit like if I'd seen a logarithms question, had no idea, and then learned about logarithms, like the light being switched on, and I was thinking, oh right, okay, logarithms, pretty good stuff, tell me more. It wasn't exactly logarithms. That was weeks after I'd written down there, weeks after I'd printed out the question. And then the mission is to just get that down from weeks to minutes, which is surprisingly something that you can do. But I really did start at weeks for solving questions and get down. Good. Factorising this was a nightmare, says Mames John Rowe in chat. We're going to find out. We got fewer votes on this one. Possibly because people are still doing it. I'm going to start doing it as well because Lando Norris in chat asked me to. There is also a running joke for people who are new. Lots of people, for reasons I don't understand, have picked Formula 1 usernames in chat. So there's lots of Formula 1 drivers around. Okay, first term was x squared. The next term, I'm going to use two things going on here. There's a power of x. There's a power of x on the top and the bottom. So this is the same thing as c over b to the power of x. So this is x times, and then I've got this fraction thing, which I'm going to write as log base a of c minus log base a of b. I love logarithms. And then this term at the end, I think I'll do a negative sign trick on that one. I think I'll throw a negative sign in. There's this 1 over b thing, right? This is not too bad, right? Not too bad. There's a minus sign here, and there's a, whoa, what's going on in here? X times, there's two x terms, and there's a minus sign over there. So it's got a and b and c in it, and I want to do a kind of quadratic thing on it because it's turned into a quadratic. So I want to do the kind of b squared minus 4ac equals 0. So I think I want to do something like log base a minus log base b squared minus 4 times 1 times the last term. Mames in chat has told me that this was a bit of a pain to factorise and simplify. I don't think it's going to be that bad, right? I quite like these ones, by the way, where it's a quadratic and it involves letters A, B and C, but they're not in the right places where you're expecting an A, B and C. It's kind of, I don't know, rewiring which things are A, B and C in the thing. Like this whole thing in square brackets is kind of B, but don't call it B because we already have a B. So, I don't know. I think this is going to turn out to be log base A of C plus log base A of B squared equals 0. What am I doing? So I want this to be 0. This is when it's got a repeated root. Let's put some words in. I'm always telling people to put words in. Repeated root if, and only if, this thing is true. Just reckon when I multiply this out, I'll get a squared term, and a minus 2 times the product. And this is going to be plus 4 times the product. So it's going to bring it up to plus 2 times the product. And that's the same thing as if I've multiplied it out with a plus sign. I feel like I've seen this sort of thing before. I don't know where, but I feel like I've seen an x plus y squared minus 4xy or something. Like this has caught me out before. So I can do it quickly because I know roughly what happens. That's gone. I don't know why I rubbed that out. Good, right, cool. How's chat doing? Chat's doing alright? A few more people have got to the answer, possibly because we're getting there. Yeah, so difference of 2 squares. Is it the difference of 2 squares? It's kind of the difference of 2 squares, isn't it? I suppose the 4 term is the difference of 2 squares. Good, okay. So we want this to be equal to 0, but now I can combine these things back together again, right? Log A of BC is equal to 0. Use the product thing for logarithms. What do I really want? So what I really want is BC to be the number that you get. I want that to be a to the power of 0. which is 1, I think. So I want b times c to be 1. So I've got the number d. I've got the number d. What are we going to do? What are we going to do? Oh, we're going to look at chat results. Chat, here we go. There we go. Chat's got there as well. Chat's at 89%. I like that. Good. Right, cool. Back to chat. +4, -4 thing is really useful for further, says Anonymous, for maybe, I guess they mean further maths. James, what did you just do? They said about a minute or two ago. What did I just do? I did a whole bunch of logarithm nonsense at the start to get that x squared by pulling down the powers, to get this term by pulling out the power of x, this is c over b dx, and then there's fraction stuff, like when we had the 2/5 before. And this thing on the end is just a minus sign from the log a. This is a quadratic. Love a good quadratic. You look at these things as the coefficients, and you squint, then it sort of looks like x squared plus blah times x plus a number on the end, or minus a number on the end. So we're doing quadratic science to it. Okay, line 2 to line 3, says Adam. Of these lines down here? Yeah, okay. These lines, Adam. Yeah, I squared it and I added on the 4, and then I recognised it as a square all at once in my head. Sorry, that's not very helpful, is it? The terms are really awkward to write out, so being able to do this quickly is good because it saves me from writing out log subscript ac. But what I'm really doing is this thing. Let's write it out like this. So what I can see when I stare at this is +4 times some stuff. And what I can sort of see is this. And I've just sort of seen this shape before, I guess. That I know this is going to be purple squared minus 2 times purple pink plus pink squared. And then I'll add on the 4 times purple pink. I have minus 2 times purple pink, add on the 4 times purple pink, and I'll get plus 2 times purple pink. And I've seen purple squared plus 2 times purple pink plus pink squared. I've seen that so many times that I just don't want to write down purple squared plus 2 times purple pink plus pink squared, because I know it's purple plus pink all squared. So that's why I just wrote down this line next. And I really wasn't thinking, I wasn't thinking about purple and pink, but I also wasn't thinking about log base A of C, log base A of B. Like I don't have those syllables in my head because it's really long. I'm just thinking thing, a different thing. These match up over there because I guess it's pink times purple, right? It's slightly harder to spot because they're in the wrong order over there. But multiplication is commutative. Why don't you just write it out? Writing is slow, and I'm trying to be fast. I guess I'm also trying to explain, so writing it out would have been good for explaining. But hey, where did the 4 come from? It's from this rule that like b squared minus 4ac. Quadratics have repeated roots if b squared minus 4ac is equal to 0. That's just how quadratics work. This is a quadratic in x, and it's got a repeated root if b squared minus 4ac is 0. Good. Right. Okay. Not really sure. As always, when I go back and explain things again, I'm not sure if I'm just making it worse, because I tend to say something that's quite similar to the thing I said the first time when people wanted me to do the thing. It does feel like completing the square, right? And we talked a little bit before about completing the square. Yeah, I like that, thanks. Is it just completing the square? It's a very similar skill to completing the square, in that I'm thinking about what the square is going to be and avoiding writing out too much stuff. These are questions from the first section of math. Yeah, these are all from question 1 so far, and I think today just from the first bit, the multiple choice bit. Multiple choice section on math is worth 40% of the marks, so it's worth getting it out of the way as quickly as possible, I think. So if you can do it quickly, then because it's just multiple choice, you can just tick boxes. There's a request. I don't know if this is sincere or not. I'm going to take this as a serious request. Please don't do stuff in my head. It's confusing. Okay. I will take that in mind. Bear that in mind. I'll do less stuff in my head. Biggest Triangle wants to know, in a clear bit of identity left, would like to know how many minutes they should spend on question 1. I asked the first years this. So we got the first years. I sent them a survey to ask them how long they spent on question 1 on the mat. amongst some other things as well. And they generally said about 45 minutes, and between 30 and 60 was what they came back with. Next year I'm going to give them more options on the question when I ask them. But people seem to be spending less than an hour, which surprised me a bit because I would have guessed that people spent about an hour. People spending a bit less time. Here's another short question. This one's quite a bit harder, so we'll see how chat does with this one. Tips to improve at question 5, and I saw someone ask about the logic questions on like question 6 and stuff as well later on. Sorry, they asked the question earlier on. Question 6 is later on in the paper. We've got a workshop, we've got a live stream coming up in a few weeks on questions, on recursion questions, which is going to have some, I hope, helpful advice about this sort of thing. But broadly right now, I would say these questions tend to not use so much of the syllabus maths. So a lot of the live stream sessions are going through the syllabus and checking you understand the stuff from A-level maths and helping you revise it and get ready. Lots of question 5 and 6 tends to be a little bit more separate from the maths on syllabus, and a little bit more logical reasoning and things where it's not necessarily directly the thing on the syllabus. It's maybe a bit more fundamental. I quite like the Enrich website, N-R-I-C-H, Enrich website, for just other problems that aren't necessarily to do with the syllabus but are tricky and involve logical reasoning. And maybe that's one thing you could do, is to just sort of throw yourself out of your comfort zone and just look for other questions that aren't necessarily on logarithms. Like everything we're doing today is logarithms. You logged in today, maybe expecting to see some logarithms, and hey, here's a whole bunch of logarithms. Maybe seeing random other questions from other places is useful. UKMT on Twitter do problem of the month, or is it problem of the week? UKMT on Twitter do some stuff like that. And there's also, big fan of the Enrich website. Link in the chat for Enrich. Sure, go on then. Here is the Enrich website. It is a bit sorted out by, it's coming now, there we go. The Enrich website is a bit sorted out by age group. I tend to ignore all of the age ratings on things and just find anything that looks interesting. We did a couple of exercises from that website on the Maths Club. We talked about some things from there, with a problem about sort of crossing a river, which is not quite a math problem, but could maybe have been a bit similar to a math problem like that. Pierre de Fermau wants to know if I recommend doing STEP, even if it's not needed for uni offers to practice math at uni level. STEP's an open examination. Anyone's allowed to use STEP. I quite like the STEP foundation problem, STEP foundation modules for preparing for stuff. And I think the STEP paper itself, there's loads of past paper questions if you want to see more stuff. It uses loads more maths than the maths, so be aware of that. But I think it's an interesting resource, even if you don't want to do the exam. Biggest Triangle also recommends TMUA, or maybe they're saying that TMUA and CSAT recommended Enrich as well. Who knows? Step 1 sadly no longer, well, Step 1 exists in that all the past papers are still there. They're no longer doing that exam. So, the question was about exams, I think. 1F. Oh, right. SV's had a go at the question, which reminds me that there's a question on the board. It's a logarithm question from the mat. The options on this one are a little bit confusing. There's a hint in blue that I've written for the worksheet. The hint's not part of the original mat question. The hint's for you, for this, for now, to try and explain that, is it the case that either you can solve this system of equations or you can't? Maybe this all works out and you can just solve it, or maybe not. And if you can't solve it, then it might go wrong in different ways. And the question is trying to get you to, rather than just solve the equations, okay, so no spoilers, but the question maybe could be written. You could imagine a similar question that says something like, solve these equations, and you have some numbers, and the options are different values of A, B, and C. That would make sense as a question, and perhaps it would make more sense when you read it, that there'd be some equations, and you'd be like A, B, and C. Confusing because the options are also labelled A, B, C, but the options would be like A is 3, B is 2, C is 5, and the next one would be like A is 3, B is 5, C is 2, and then there'd be 5 of them to choose from or something. I think the reason the question is not phrased like that is that it would be too easy to just plug the options back into the logarithms to say, oh, I'll just check. There's only 4 possibilities on the screen. I'll just check them one by one. I'll check all of them in the logarithms and see which one works. Now, that would be quite a sneaky, clever thing to do. There's nothing to stop you doing that if that question comes up. It's not really the spirit of the question. It's not really what we want to get in with, which is, can you solve these equations? Which is, I think, why the question has been phrased. Rather than telling you to solve it and check your solution against one of the options, I think it's been written in this slightly more confusing way, so that you have to actually go and solve it, so that you can check that it does have a solution, I think. Right. It is phrased a little bit weirdly, but it's kind of to stop people cheating. Well, not cheating. You're allowed to use the information, you're allowed to read the options, you're allowed to look at the options, but it's to stop people from being a little bit cheeky by doing a strategy where they don't actually engage with solving any equations. I'm not saying, by the way, that when you see this question, it's necessarily the case that there's a unique solution. It really could be the answer. There could be multiple solutions or no solutions. That could happen. That'd be just as good a question. Sorry, that was a bit behind the scenes, a little bit meta, a bit complicated. I am so excited that James Maynard is famous enough that somebody has chosen James Maynard to be the person they're pretending to be in chat. And in a room with like Gauss and Fermat, I am so excited that somebody's picked James Maynard as their pick. The great thing is that James Maynard is alive and doing number theory and is in number file videos. You can just go and see James Maynard do some stuff. Brilliant times. Oxford mathematician here at the moment. We're all very excited. Okay. Oh, maybe it is James. If it's the other James M, then hey. Thanks for checking in. Right, good. Okay. Trying all the options is not as fun as actually doing the question. We should do this question, shouldn't we? First step, I think, is to get rid of the logarithms. So this thing over here is log base b of a means the number that you would have to raise b to the power of to get a is 2. So this says that b to the power of 2 is equal to a. And this says that b to the power of 3 is c minus 3. These are kind of related, I suppose. And this says that a squared is c plus 5. And then really the question is, can we solve these equations? We've got 3 equations, we've got 3 variables. They're non-linear, it's all a bit weird, so it's not obvious we can solve them. So we can go for it. Have I met Brady? Yeah, Brady did a panel thing at a conference that I went to. It was really good. Good. Okay, let's do some maths, because it's what we came for. I would like to try and solve these equations. It's a little bit weird because there's a cubed in here. I think in school I learnt about systems of simultaneous linear equations, and I learnt a little bit. I did some stuff with plugging quadratics into each other, and then it all got a bit confusing. This is going to be complicated because there's b cubed. I'm going to try and, what am I going to do? So I could cube this one and I could square this one so that I've got b to the 6 on both of them. Something tells me that would be a bit complicated. I don't really want to cube this a one over here. Maybe I should do it like that just because I can. Or maybe I can't. Crisis, what am I doing? I think the way I would probably start is to use this first one is not too bad. It says a is equal to b squared. That's pretty good. If I imagine flipping it around, a is equal to b squared, that's going to let me eliminate a. And actually this one looks like it will let me eliminate c as well. Maybe. We'll think. Maybe I want to eliminate a. Yeah, eliminate a and c. Let's eliminate a and c. These are not too bad. If I write them as a is equal to b squared and c is equal to b cubed plus 3, I can eliminate a and c. What are people saying in chat? Eliminate c is popular in chat. Yeah, okay, so let's go. A squared is then b to the 4. Thank you, Gauss. This is b cubed plus 3 plus 5. So now I've just got a 4th order equation, I suppose. I can't see any obvious solutions straight away. Oh, maybe I can, maybe I can't, not sure. Can I think of any solutions to this? I think b equals The 8's multiple of 2. Just makes me think about 2's. Yeah. And then that a squared anonymous, I'm going to get rid of that a squared as well. I'm going to make that b to the 4. And then we've all got this equation, right? B to the 4 is equal to b cubed plus 8. So I want to know, I suppose, I'm pretty sure this has got a solution because b to the 4 is really small when b is 0, and b to the 4 is really big when b is large, so somewhere in between there's a solution. So I think it's not got no solutions. I think it's got at least one solution. I'm a bit worried. Some of these options talk about having multiple values of A. I haven't really thought about A, I'm thinking about B at the moment. But you know, people in the chat, 5 people at once have told me that B equals 2 is a solution. Yeah, 2 to the 4 is 2 cubed plus 2 cubed. That's true. Guessing solutions to polynomials, good technique, gives you solutions to polynomials. Can't complain with that. I can't see any other obvious ones. I'm going to have a quick think, is that it? Is that it? Is that all of the solutions? Sometimes it's helpful to think about the graphs. I'm trying to think about b to the 4 versus b cubed plus 8. I'm going to try and sketch those really quickly to show you what I'm thinking, because it's in my head, and I've been told if I keep things in my head, it's greedy, right? Keeping them in my head is greedy. I should be showing them. B to the 4 looks like this. And b cubed plus 8. I think this is like last week on the graphs one. We tried to draw some graphs, mixed results. B cubed plus 8 is like this, right? Okay. Maybe not, because b cubed is going to grow slower, isn't it? I've changed my mind. I've got to go through 2, haven't I? I know that 2 is on both of them. I guess cubes grow slower than squares. Let's do one more attempt. There we go. Yeah, I'm trying to draw the cube going slower and the b to the 4 thing going fast. B to the 4 gets fast really quickly because you're multiplying by an extra b. When b is like 10 or something, it's about 10 times bigger. Okay, and I think there is another solution, but it's a negative number because b cubed plus 8 is positive at 0 and it stays being bigger than b to the 4, and it stays being bigger for a few negative numbers and then not all of the negative numbers. Okay. Can you graph it in 3D? Oh, no thanks. Oh, graph A, B, and C. Oh gosh, yeah, they're all like surfaces in 3D. That's certainly an approach you can take if you want to. It's a little bit. I'm making noises because it's a little bit like, how do I sketch these things in A, B, C space? They're like really complicated surfaces. No thanks. Oh, B says B must be positive. It says right up here, B must be positive. Thank you. B must be positive. I've only got one positive solution, I think. I think I've only got this positive solution because b cubed plus 8 gets a head start from starting with this 8, but it's growing slower. By the time you get to b equals 1, it's got up to 9. B to the 4 is still down at 1, and then after that, it's growing slower than b to the 4. B to the 4 is now off and away growing really quickly compared to b cubed. So as soon as they pass each other at 2, b to the 4 is now getting bigger faster. Good, I've convinced myself, which is all I have to do because it's a multiple choice question. Good. B is also the base of the logarithm, so it has to be a positive number. Brilliant, that's probably why they've told us that. I think there's just one solution. One solution, if b equals 2, and then I can work out the other ones from this, can't I? So a would be 4, and then c from b squared equals a, and then c would be, well, this would be 8 plus 3 is 11. Seems a bit unlikely, but hey, does that work with this one? A squared 16 is 11 plus 5. That's true. Yeah, cool. And all the logarithms work out as well. We've got 3 positive numbers. So I think it specifies A uniquely. I think we're good. I think it just solved. You can just solve it to get 4, 2, 11. That's my solution. Good. Yeah, so zooming in on that bit then. If b to the 4 equals b cubed plus 8, then b cubed has to be 8. I guess that's what I've claimed for positive numbers. Is this feels like Anonymous is going somewhere with this to say a long and windy route to do this. Yeah, you can sub the equations into each other differently. Why am I solving for b instead of a? Because I know that a is just b squared. So it's fine for me to just think about b and then right at the end to just be like, oh, and by the way, a is just the square of b. So once I've found out my solutions for b, if I've only got one number for b, well, I can only really get one number for b squared. Cool. Use the forbidden quartic formula. Yeah, so you can actually solve these. Well, you can't, I can't. Some people out there can. If they're watching the video, they will let us know in the comments that they can solve quartic equations using the quartic formula. It's not forbidden, it's just really messy. Good. Right, okay. Not very satisfying because we didn't really engage with what B, C and D would probably mean, but because it just had a unique solution, which we found. We did it, and I didn't switch on a poll for that one. I thought that was a bit too complicated. Let's linger a moment. I'm not going to move on straight away. Partly because we've still got time, and partly because this is happening. Ben, that's a great suggestion. I want to do that. Yeah, I want to do that, I think. Let's try and do that. I've convinced myself, but I should convince you more. Long division. Yeah, let's go long division. Okay, Ben's got this great idea where we take this equation. We know that 2 is a solution, so let's think about the cubic that's inside here and think about whether it's got any other solutions. Oh my goodness. Division minus 4b. I've got one term wrong. Plus a 4 because I don't want any b's. Minus a equals 0. Right, and then all the terms are positive, so this is the sort of cubic. Oh, brilliant. Thanks, Ben, in chat. This is great advice. All the terms are positive, so this cubic here, this cubic, is the sort of cubic that just increases. It starts at 4, and it's got a positive gradient. It's just going up, 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 up. It's positive everywhere. Is that true? double check that this has got positive gradient everywhere. 3b squared plus 2b plus 2 is equal to 3b squared plus 1/2 squared quarter 3/4 plus 1/4. Yeah, okay, good. It's always positive gradient, so it just keeps going up. So that's a terrible picture of a cubic, but it just keeps going up, and there's only one other solution somewhere over negative side. Brilliant. Am I doing? No, that's not. Okay, okay. I'm getting told off. Because I didn't do my log. I learned the quartic formula in 30 days. I sort of really do want to do a quartic formula thing. You do the video would go cubic formula, quartic formula, and then a really good bit about why there isn't a quintic formula. But I need to learn. I don't know Galois theory, so I need to learn loads of Galois theory first. Because I want the video to include, like, oh, by the way, here's some Galois theory. My hurdle is that I don't know Galois theory. Yeah, let's not use the quintic formula. Because there isn't one. Good. People cross with me for doing that long division too quickly. I'm not doing it slower. Sorry. It's just not worth writing it all out, right? I've realised I said long division and then I failed to do long division on the board, but you don't actually want to see me do any long division. Quartic formula in 30 days. Right, good. Good. There's a trick for the cubic one. The cubic one probably makes a good YouTube video. The quartic one probably doesn't make a good YouTube video on its own. And if you put them together, it's a very long YouTube video. It's not very optimised. Kai was not serious. Oh, maybe they were not serious about wanting to do the longer version or something. What did Kai say? Stuff in head, right? Cool. Okay. We're going to do one more question. It's only 6:30. I think I might come up with some more maths to do afterwards. I'll have a think. While we're doing this one, I'll also think about what we'll do afterwards, because it looks like we're going to have a bit of time left. 2 hours is the correct length for this. Good. We're going to solve some quartics. We want to learn how to do it quickly as well. Do you want to learn how to do it quickly? It's imagining what would happen if you multiply it out, right? Multiply it. What would happen if you multiply it out? So write down the b cubed, because I want a b to the 4. And then I imagine what would happen if I multiplied this out. Oh no, I would get minus 2 times b cubed. Fix it. How can I fix that? I don't want minus 2 times b cubed. I want minus 1 times b cubed. I will fix it by writing down a b squared over here, so that the b squared multiplies by the b to give me a b cubed. That was brilliant. Instead of minus 2b cubed, I fixed the problem. I'll get minus 1b cubed. Oh no, I will get minus 2 times b squared. Panic. I don't want minus 2 times b squared. I want no b squared. So I should add on a 2b so that I get plus 2b squared. plus 2b squared, that's brilliant, I've solved the problem. Oh no, I'm going to get minus 4b. Minus 4b, I don't want minus 4b. I don't want any of these at all. I'm going to add on the 4 so that I get 4b when I multiply it out. Brilliant. And I also get minus 8, which I did want. Good. That's what's going on in my head. Good, okay. I learned more about myself doing this than I thought I would. Good, okay. Was I this fast at math? I was faster at maths when I was going for university. I've become old and slow. Right, good. And I make way more mistakes now. Like the famous cube one. Do you need to know the solutions too? Not really, no. Not with the way the question's worded. There's a weird side effect to the question. You can get the numbers wrong, or not even, just not notice that the solution is the number 2, and still answer the question correctly. That's multiple choice, so you get the marks. Sorry. This question in chat. Without guessing b equals 2, how would you find a linear factor? There is no good answer to this question, and I think that's neat. I mean, there's the Quadratic formula, but in general, because what they really means for polynomials, right? What this question really means for polynomials is, if you see a polynomial, how can you tell me a root of that polynomial? And there's no good method for writing that down using radicals and normal expressions. Good, okay. Right, multivariable polynomials, how do you do? Yeah, okay. Right, good, okay, here we go. We've got one more question before we do something slightly more experimental. It's a question 1J. We sometimes sort them out a little bit so that we put a nice one at the front and we put whichever one we think is hardest at the end of question 1. Don't always get that right. Sorry, sometimes the first one we picked is not quite as easy as we thought, and sometimes the last one, well, sometimes one of the middle ones is worse. Oops. But we have a go, so that you get a nice experience on the first one, hopefully, maybe, and then the hardest one's got to be somewhere. What I'm telling you is, I think this question is quite hard. People in the chat think this one takes a long time. This function is, by the way, sometimes called the floor function. Yes, this person in chat has seen this function before, maybe. Floor, because it takes stuff and it rounds it down, which is where the floor is. There is also a function called the ceiling function, which takes all the stuff. Okay, good. It's the largest integer whole number that's less than or equal to x. So, for example, floor of e is 2. Good. N is a natural number. Back in 2013, I think we expected you to know about integers and natural numbers and those phrases. And now I think you probably still do know those things, but, they're not really sorted between A and J. There are a little bit, I think, but who knows. A sketch is a very good idea, JWC. Physics girl here for fun. Right, good, okay. Year 13, James was not very chill. Good, but pretty good at multiplying out brackets. Wow, he sounds like a loser. Have you seen his personal statement? Definitely a loser. Is 0 a natural number? Yeah, right, okay, this is the sort of problem that you face when you say natural number in the question. I think it is. Doesn't matter for this because the things being put into the floor function are all 1 or bigger, but gosh, confusing. Yeah, and sometimes people write it like this for the floor, usually because they're using this one for the ceiling function. If the question doesn't have ceilings in, then it's probably easier for everyone if you just write square brackets, so that people aren't weirded out by your different symbol. But they're easier to type, I guess. I'm being silly. Right. Okay. What are we doing? What are we doing? We're going to do a sketch, I think. Let's do a poll. Yeah, similar question in step, but similar question. I've seen similar questions where it's either 2 to the power of floor of x, or it's floor of 2 to the x, or sometimes something else that's sort of slightly different from either of those ideas. But both of those functions are quite interesting. Both of them behave in quite a strange way. I'm going to try and do a really big sketch. I have loads of space today because I've worked out how to do spaces. Okay, so I'm going to try and draw this function that we've been asked to integrate. Integration is coming up next week, Is it next week for integration, maybe? Number 5. Can I try and use some features as well? Look, we've got time, right? I'm going to try and draw this. If you're annoyed by me trying to draw things, then fast forward. If you're watching live, we're all here together. And it's not going very well. Shape, really thin rectangle. Yeah, really thin rectangle. There we go. That's awful. I hate that. That is awful. Nasty. There's a straight line options in there. I promise it's joining to that thing because I'm drawing on top of a thing. If you're fast forwarding, then good. Well done. Type, straight line, thickness up, straight line, straight line. Oh no, because it's on top of the page. There we go. There's a straight line. Welcome back. This is the most pathetic attempt at drawing straight lines anybody's ever. I'm not doing this again. Well, I'm enjoying myself, and that's the important thing. Right, okay, we've got some axes. These are the x and y axes. We're going to try and draw 2 to the power of x. Floor. First, I'm going to try and draw 2 to the power of x. So 2 to the power of x works like this. It starts at 1. 2 to the power of 0 is 1. Welcome to the Oxford MAT Livestream. And then it grows quite quickly, I suppose. Faster and faster and faster. Is it a disadvantage to have a personal statement like James's? There is the question. Get a time machine for the guy. Get a time machine and tell him, you know, get a time machine. You know, in 10, 15 years, you'll be in front of some people and they'll say, do you know, is my application disadvantaged if I'm like you? That'd be really bad. Anyway, so this comes up to the value of 2 at some point. I'm being a little bit sneaky about when it does that. I suppose it hits 2 at the value when x is 1. I'm going to shuffle all this left a bit. So it takes the value of 2 when x is equal to 1, which is good news, I suppose, because now the floor of the function is going to be 2 for a bit. How long is it going to be 2 for? A while, I suppose. This function goes up to 3 at some point. Let's try and draw that a bit more convincingly. And it goes up to be the value of 4 at some point. And I'm going to work out where that happens. I suppose this 4 over here happens when x is 2, because 2 to the power of 2 is 4. And this point in between is a bit more mysterious. This point in between is, I suppose, the number. Here we want 2 to the power of question mark equals 3. So I suppose that question mark is log base 2 of 3. Okay. Still a bit mad. Yeah. So that ceiling, I'm rounding down, I think. So my pink line is 2 to the x. And my floor function is going to be the biggest whole number that is less than the pink line. I think. Let me just check that I'm doing the right question. Largest integer that's less than or equal to x. Okay, so to start off with, that's 1. And then it's 2 for a bit, and then it's 3 for a bit, and then it's 4 for a bit. And this keeps going. Okay. Oh, is that a Desmos chart of the actual thing? It says Desmos. Let's have a look. Desmos includes all these straight lines by default. And it's not loading for me. Do I need to switch on something? No, can't work out how to make your Desmos work. I think my computer might be unhappy with your Desmos. It's trying to do the integral really slowly. Technical difficulties. No, okay, it's gone. Can't make your Desmos work. Where did that log 3 come from? Yeah, so I knew that I wanted the number here, this sort of x or something, to be the number where 2 to the x is equal to 3. And I know about logarithms, what we've been doing today. That means it's log base 2 of 3. That's the point where the pink line goes to 3. Going to the number 3 is magic. It's good times because now the pink line is somewhere between 3 and 4. And if it's between 3 and 4, then we're going to round it down to 3. Good. So we're applying the floor function. The floor function takes things and rounds them down by returning the largest integer that's less than or equal to x, which means rounding it down. Like the floor of e is 2. The floor of pi is 3. The floor of these things between 3 and 4, don't know what they are, but they all get rounded down to 3. Maybe I shouldn't say rounded down because people have got strong opinions about rounding. The biggest whole number that's less than the pink line is now 3 for that bit. And then it's 4 afterwards. Okay. So Ben's talking about areas in chat. And I think we do want an area because we want to do, my goodness, we want to do the integral, we want the area, oh my goodness, all the way up to x equals n for some whole number. X equals n is where the function is 2 to the n. And what was it before that? I guess the function was really briefly 2 to the n minus 1 for this tiny bit of graph. This tiny bit of graph where the pink line is between 2 to the n minus 1 and 2 to the n. There's a bit of function over here. So in between we've got all these kind of steps. Having steps in your graph is normal for things involving the floor function. Floor function is just like that. This biggest whole number takes whole numbers. They jump by about 1 each time. So it's got this rounding down thing going on. And in between there's all these steps, I suppose. Where's my blue line going to go up again next? So it's at 4 at the moment over here, down on this bit. It's going to jump up to, I suppose, 5 at, just following my pattern here, log base 2 of 5. And then I suppose it will jump up to 6 when we get to log base 2 of 6. Okay. And then this 2 in here was secretly log base 2 of 4, and this one was log base 2 of 2. Is the area some sort of sum of geometric series? People are ahead of me, I think. Key ideas for the rest of this question. We're going to think about this area underneath the curve. So in blue I've got this one. This area underneath the curve. And I think it does turn out to be some sort of nice series, maybe a geometric series. If you don't know about geometric series, then there is a live stream from a couple of weeks ago about geometric series in this playlist. I don't really know if YouTube playlists are still a thing, but hey, I think we've made one and it's got these videos in. If not, check the channel that this YouTube video is on. Or check the table, which has links to previous episodes, provided I read this post-it after the live stream. Okay, what are we doing? We've got this area, because integration means finding the area. Is it going to turn out to be a geometric series? Ooh, okay. Physics girl here are fun. Surely you prefer series circuits that are in series? That would be a different sort of series that's more physics-y. Anyway, never mind. That was not as funny as I thought it would be. Anyway, how big is this area? I think it's loads of rectangles. And I think the rectangles work like this. They have different heights. Their heights are like this. Oh, that's a horrible colour. Writing in. Horrible colour. Their heights look like this. 1, 2, 3, and so on. And the last one, its height is 2 to the n minus 1. And the widths, look like, the first one is width 1, the second one is width, oh my goodness, that's log base 2 of 3 minus 2, and then the next one is 2 minus log base 2 of 3. Should we do some more in between? I haven't really seen a pattern here for the size of these rectangles. Mission be funny, : fail. And what's that height of, the width of that last one there is really narrow, isn't it? This point over here is log base 2 of 2 to the n minus 1. That's the point, I mean, believe it or not, that's the point where 2 to the x finally hits 2 to the n minus 1. Just before, we're nearly there at 2 to the n, it hits 2 to the n minus 1 at log base 2 of 2 to the n minus 1. That's just what logarithms do. So that's the width of this one. No, it's an n minus. Get the n minus in there for the width. N minus log base 2 of 2 to the n minus 1. Close bracket, close bracket. There is a mistake in the second term, thank you. Log base 2 of 3, minus 1, thank you. That's a 1. Thank you, catching that very quickly. Kai's got there, Kai's spotted that as well, thank you. This is Ben less effort trying to be funny, more time trying to do this. Lewis has got a really interesting idea. Can we do it the other way round? Have each interval along the x-axis be 1 and then the powers of 2 on the y-axis. That's really interesting. I think, Lewis, you're calculating the area above the graph, which is allowed. Maybe that's a really good idea. Maybe that's a really good idea. Right, forget this. We're going to do Lewis's method very confusingly. We're going to switch to doing Lewis's method because I've been suddenly taken by how I think it might be a brilliant idea. Lewis's method is this. Right, okay, so pause this idea that's on the screen at the moment. Pause it, because you could go and rearrange this and simplify it, and I think the worked solution on the website, link on the screen, worked solution on the website goes and does some stuff to rearrange this, and it's quite slow. Lewis has got a suggestion to do it the other way. I think I saw someone else do this integrating sideways in rows as well. Was it Ben earlier? Got stuck, looked at the answers, found the next step. Looking at the answers is a bit like that, isn't it? Right, okay, we've parked that idea. We're going to come back to it, maybe, or maybe not, who knows. Lewis's idea, I think, is to draw a big rectangle. I know, I'll use the rectangle tool. I'll use the rectangle. It's what it's there for. To draw a big rectangle around this. Yes, a big rectangle around this. We know the area of this big rectangle. We know how big rectangles are. The rectangle is 2 to the n tall on this side, and it is n tall wide on this side. 2 to the n. There we go. And Lewis's plan is, instead of working out this blue area, which is very, very fiddly, we could work out the area above the curve. The area up here. I'm going to colour it in a horrible orange colour, sorry. This area up here. Above, not above the pink curve, but the area above the function. And I guess Lewis is looking at this sideways as a bunch of rectangles this way around. All of them have, I'm going to call it height 1. And their widths are these numbers that we've just been finding. This is pretty brilliant, actually. I like this. Do you see? We're going to work out this orange area and we're going to subtract it. Okay, I'm going to keep working in orange so it's clear we're doing something very, very different. What are the widths of these rectangles? That first one is, unbelievably, that is a square. It has height 1 and width 1. Let's quickly zoom in on this square. Yep, definitely a square. So that's got height 1. They've all got height 1, so I'm not going to write down my heights. I'm just going to write down my orange widths. And this is the orange area. It's going to be 1, and then the next rectangle up, this one here, that has width log base 2 of 3. Oh, this is lovely. And then the next one has width log base 2 of 4, and then log base 2 of 5, and so on and so on and so on. And the top one along the top is going to be n, isn't it? It's going to be log base 2 of 2 to the n. That first one I'm going to write as log base 2 of 2. Just have a feeling it'll be nice like that. Look, this is brilliant. I'm also going to put in, yeah, okay, so this simplifies really nicely because you can use the multiplication rule for what happens when you add together logarithms. Together, this is just log 2n factorial. Oh, I shouldn't use square brackets anymore, should I? 2n factorial logarithm. So that's the orange area. So then final answer is just going to be something like n times 2 to the n minus log base 2 of 2 to the n factorial. Is that one of the options? That is one of the options. That's option B. Oh, very good. Yeah, I kind of skimmed over my log base 2 of 1. Yeah, Ben, I'm with Ben, sorry, I shouldn't have done it in my head, right? Secretly, there's a log base 2 of 1 in here. I mean, log base 2 of 1 is 0, so this is uncontroversial. But log base 2 of 1 is I have this rectangle down here, right? This 0 width rectangle. This is equal to 0, this step here. I mean, that's included. And it makes the thing simplify nicely. That is very nice, isn't it? Log base 2 of 1. Good job, Lewis. The thing in blue does rearrange to give this thing as well. So that's all right. So that's nice. There is a general bit of advice here, actually. Let's do the general advice. It's not very general advice. Sometimes I say general advice and then I say something really confusing and vague and massive, but this is going to be a separate thing that I've seen. If you're trying to integrate a function, the normal thing to do is to integrate under the function. but you sometimes have this choice to do this rectangle trick that we've just seen Lewis employ devastatingly effective on this problem. But you have this in general. If you want to integrate a function, it doesn't have to be this kind of steppy rectangle one. You do this function, or you could integrate the inverse function that way around. People don't really know. Am I going to get away with this? So if you've got the general result of what you write down is pretty horrible, but there's some relationship that relates together the integral of the inverse function of y to the integral of the function itself, f of x dx. These things are related together. If you know about substitutions, then you can prove it by doing some cool substitution tricks. But these things are related. Depending on what f is. If f has to be an increasing function, I think. So that you don't get any funny business with like shadows of weird bits of functions that double up, I think. I think that's true. These are related. Cool. How do I go from factorial to the answer? So Lewis's big plan is that that's the orange area, there's some of these rectangles. What we really want is the sum of the blue rectangles, which is the other bit of the big purple rectangle. So the big purple rectangle is n times 2 to the n. That's my kind of purple rectangle term for the big purple rectangle. And then this bit here that's been subtracted is taking off. Chisel away all of these orange bits along the top to just leave this picture of bits underneath. Cool. Could it be a decreasing function? Yeah, maybe it could be a decreasing function. That's still fine. It needs to be monotonic, I guess. Or does it just need to be? Okay. It just needs to be a surjection, but no, and it needs to be a bijection. But that's not important right now. Right, cool. Okay. Are we assuming that 2 to the n is an integer? Yes. I think we're told that n is an integer. N is a natural number, which is a sort of integer. So 2 to the n, we're lucky, that's an integer. Cool. Why is it we learn the definition of derivatives as limits, but we learn to solve differential equations by treating them as infinitesimals all of a sudden? Yeah, if you would like to treat your derivatives as limits, then you're going to really like university. University is going to really answer that question. There's whole courses at university which are kind of motivated a bit by how to actually treat derivatives properly. Good. I thought we'd have loads of time left. We've got 8 minutes left, so I'm actually going to look at the extension, which I don't normally do. Good. So yeah, that's one in the chat says there are no logs longer questions. There'll probably be one last. There was one last year. We're saving recent papers for I guess big party. The few live streams before the actual MAT, and we're looking at past papers. There was a log one last year. I wrote it. It's one of my questions. I'm very, very proud of it. I think it's a really good log question. It involves logarithm facts in a long question. We're going to chat about the extension very briefly. That should be an n dash. Sorry, I've just been distracted because this. Look, I got this correct over here. I got this long dash. That was correct. That was wrong. That one should be should maybe be a colon, right? I should have paid more attention in like English. Anyway, if I'd known that I have to write text. Mains Genro, great news. There is an open day on the 16th of September. Thank you for reminding me to advertise the idea of open days. Here is a page about open days for us to look at very briefly. Open days and visiting. Oxford's open. There is an open day happening on, where's the link? There it is, 16th of September. Which is next Friday after next. There's going to be maths talks. Well, only a couple of maths talks because mostly the open day is a chance to go and look at colleges, to go and have a look around Oxford. It'll be really nice. Good. There's advice about maths and philosophy. I don't know if Prisma is answering that one. Thank you very much to Prisma for moderating chat for 2 hours, rejecting any inappropriate stuff, approving all of the banter. Hashtag ads. Hashtag sponsored, I think. I mean, I'm in my office, I'm doing my job. Do you have to say sponsored if you're doing your job? I'm paying my wages. What's my favourite college? All the colleges are brilliant. can you find all equations such that you can cancel out the d's in dy by dx? So this is a challenge that we've been given from chat to solve this differential equation, which is not that hard to solve because you can do. I mean, it turns out that you can rearrange it and then integrate it. You can do separation of variables, which you learn about at some point in further maths. We're now on an extension. We're on an extension. We're no longer on that maths. Later on, you learn that you can. Later on in maths, you learn that you can rearrange this and then integrate both sides to get ln y equals ln x plus a constant, and then integrate up, or do a rearrange around to get y as a times x. So the only equations where you can cancel the d's out are ones which are straight lines. They go through the origin. Cool. I think Merton College is a lot of fun. Is that what I say about Merton College? Cool, right. Here are some functions down the bottom that I wanted to include because I wanted to sneak these into the worksheet because they have exponentials in. They're called hyperbolic trigonometric functions, which sounds like a really bizarre name when you learn about them in school if you're doing further maths A level or something a bit like further maths A level. You meet these two functions. The first one is called hyperbolic cos, and the second one is called hyperbolic sine. And they're really nice. They do lots of nice things. They do lots of things that look a bit like trigonometry, but with minus signs. So they're sort of like a different version of trigonometry in some sense, which is super weird, right? Because they're just exponentials. They don't look anything like sine and cosine. They're less mysterious because you can just, if you know about powers of e, then you can just plug in numbers, get your numbers back. So that's super nice. Ben wants to call me out. Well, mod x is not differentiable at the origin, so I have done some shortcutting for assuming continuous functions. I think assuming C1. Goodness me. Yeah, tangent. There's a challenge on here to guess what tangent is, and brilliantly it was defined to be sine over cosh. I've realised that's not funny. That's just misleading. That I can't pronounce them. I don't know how to pronounce them. They're really hard to pronounce. I say tanch for this one. Some people say fan, pronouncing it like the H's over here between the T and the A. I say cinch for this one. Some people say cinch. Some people say shine. My opinion is that if you say shine, you should also say chos, which is the sort of forbidden hyperbolic function. People say fan, people say shine, nobody says chos. Chos just never gets brought up. People all say kosh. We've all agreed to pronounce that one as kosh. This one, can't really pronounce it. There are three more because, you can also imagine people defining this one and this one. It's clear once you've decided how to pronounce one of these, it's clear how to pronounce the other one. And this one, which pretty pleasingly people do pronounce koth, but maybe people should pronounce chot. But, never mind. They also secretly involve complex numbers. Prisma wants to know what year did you sit the mat, and then Prisma said something about chairs. I think they're asked about their math score, but also I think somebody was asking a lot about year 13s doing math earlier. Why do people pronounce it shine? Because it's quite close, right, to being like pronounceable. If you have sine and you put an H in it, here's the H. If you put it here, you can pronounce it. So it's kind of clearly different from sine, and it's got an H in it. So why do people do that? Because it's not how it's spelled, but it's got an H in it. So let's go for it. People pronounce this one sine, even though it says sin. What's going on? How do we all agree to say sine? We've got to remember that it's short for this word, which is Latin or something. You've got to remember to say sine, even though it says the English word sin on it. Oh my goodness. Hanging ropes is an example of something that we've covered on Oxford Online Maths Club. It was a really good episode. I enjoyed that one a lot. We solve for what shape they are. Good stuff. Does anybody use these inverse trig or inverse hyperbolic functions in the real world? Yeah, I think so. I think they're just useful for I don't want to say video games, but the kind of thing where you've got y over x and you want to do that trick from, you know that trick we had before with like m is when you've got like y equals mx plus c and it makes this angle. I guess quite often you've got lines or things that, like in your video game or something, you would like to know what the angles are because you want to do reflections of light off them or something. Kind of good. Oh, did I write about hanging ropes in my personal statement? That sounds true. I probably did. It's on this YouTube channel if you scroll all the way back to 2020. We made a video that an embarrassing number of people have seen where I read out my personal statement. At some point this year, maybe later on towards the bonus things, I think I'm going to have to do some sort of James reacts to James reads his personal statement. Somebody asked about aphantasia earlier, which I have not looked up, sorry. We're currently doing some GCSE. It's not obvious what data we're going to get on the GCSEs, so it's all what data linkage we're going to get to do contextualization. James tried to read a book in his personal statement. Hanging ropes from Makoshka. There you go. There's the punchline. That saves you from watching 1 hour of MATLAB, and importantly, it saves you from looking at my personal statement. James, remember to look at your post-it note. Table of YouTube links. Right, cool. I'm going to go and put the YouTube link to this video into the table of YouTube links where it belongs on the MAT Livestream page, link on the website. Check in 15 minutes whether I did it or not. Don't actually. Otherwise, I will see you in a week's time to talk about, I think it's integration next. Thank you so much to Prisma in chat. Thanks for everyone watching. Oh, it's gone all emotional. We're doing thank yous. See you all next week. Right, cool. I can't work out how to switch this off. I always do it. That's not off. That's my desk. Good. Right. Bye.